All right, my secondary math 2 class, we are going to be continuing to talk about trigonometric ratios. Okay, whenever you hear the word ratios, you want to think fraction. Okay, that means there's something on top and something on bottom, a numerator and a denominator. Okay, so for numbers 1 through 6, we have a few practice problems. Okay, it's asking us to find the value of each trigonometric ratio, or find that fraction. Okay, so let's go ahead and remind ourselves, what in the world does this cos, tangent, cos, and sine mean? Okay, well, let's go ahead and remind ourselves, what do these trigonometric functions look like? Okay, S for sine has to do or correlates with our opposite over our hypotenuse sine. Okay, cosine correlates with our adjacent over our hypotenuse. And tangent correlates with our opposite over our adjacent side. Okay, think so, ka, toa. Okay, so let's go over and look at number 1. Okay, so it wants cosine of x. Cosine of x. So we have this angle that we're looking at. Always identify the angle that it wants. Okay, so now looking at the angle, let's go ahead and just identify the adjacent, the opposite, and the hypotenuse side. Okay, so if this is my angle, that means this side, 40, that's right next to my angle, that is my adjacent side. Okay, that's what adjacent means. Think you live adjacent to your neighbor. This is our adjacent side. Okay, well, 30, that is across from our angle. So that is our opposite, or think it's on the opposite side as our angle. Okay, and 50 is our hypotenuse, because remember, hypotenuse is always right across or opposite of our right angle. Okay, so now knowing our A, O, and H, what 2 do we need for cosine? Okay, let's look back at so, ka, toa. Which 2 sides do we need for cosine? We need our adjacent side over our hypotenuse. Okay, so let's go back. How we write this is cosine of x equals our adjacent side over our hypotenuse. So find adjacent, 40 over 50. Okay, so now we need to ask ourselves, is this fraction in its most reduced form? Okay, can we reduce 40 over 50? Yes, we can. Okay, think they are both divisible by 10. So we're going to divide each of these guys by 10, meaning they both have that 0. Okay, well, when we divide them both by 10, we get 4 over 5. Okay, so our final answer, cosine of x equals 4 over 5. Perfect. And there we go. Okay, so let's do the same thing for number 2. So again, we're dealing with cosine of angle C. So find the angle that it wants. Cosine of angle C. Angle C is this angle right there. Okay, now let's use that angle to identify our opposite, our adjacent, and our hypotenuse. Okay, so this side that's right next to my angle, that is going to be my adjacent. So 12 is my adjacent. On the opposite side of my angle is my opposite side. And on the opposite from the right angle is always the hypotenuse. Okay, so again, what 2 sides do we need with cosine? We need adjacent over hypotenuse. Okay, so we're going to write cosine of C this time is adjacent, 12, over our hypotenuse, 37. Okay, now last thing, can we reduce that fraction? Is there any number that we can divide 12 and 37 by? There's not. Okay, so this is actually, whoops, let me get the same color. This is actually our final answer. Cosine of C equals 12 over 37. Great job. Okay, let's do number 3. So it wants tangent of x. Tangent of x. So find the angle that it's asking for. Wants x, so x is that angle right there. Okay, so now using that angle, let's go ahead and identify opposite, adjacent, and hypotenuse. Okay, well the hypotenuse, I guess, is always the easiest because it's always across from our right angle. So we always know that that hypotenuse, right, is across from our right angle, so there's our h. Okay, now our adjacent one is the one that is right next to our angle, so that's going to be adjacent. And opposite is on the opposite side of that angle. Opposite. And there we go. So now it wants tangent. So what two sides do we need for tangent? Tangent is opposite over adjacent, okay? So let's go back. So that means tangent of x equals opposite, 18, over adjacent, 24. Okay, last thing, can we reduce this fraction? Is there a number that we can divide 18 and 24 by? Yes, we can divide both of these guys by at least 2. Okay, so let's try that. 18 divided by 2 is going to give me 9. 24 divided by 2 is 12. Okay, can we reduce it even more? Yes, we can. We can divide each one of these by 3 now. Okay, I'm going to write it down here. 9 divided by 3 is 3. 12 divided by 3 is 4. Okay, is there any more reducing we can do with 3 over 4? No, there's not, so we're going to write it as tangent of x equals 3 over 4. And there's our answer. Beautiful. Okay, let's look at number 4. Okay, so it wants cosine of angle A. Okay, so find angle A. It's that guy right there. Now let's identify opposite, adjacent, and hypotenuse. Okay, if the hypotenuse is the easiest to find, just go across from the right angle. That's our hypotenuse. Adjacent is right next to our angle, so we know that 32 is adjacent. And on the opposite side of our angle is our opposite sides, and there we go. Okay, so what two sides do we need with cosine? Cosine, adjacent over hypotenuse. Okay, so cosine of A equals adjacent, 32, over hypotenuse, 40. Okay, can we reduce 32 over 40 at all? Yes, we can. They're both even numbers, so we can divide them by 2. Okay, so I can get 32 divided by 2 is 16. 40 divided by 2 is 20. Okay, can I reduce 16 over 20? Yes, I can. They're both even again. So 16 divided by 2 is 8. I'm going to write it down here. 20 divided by 2 is 10. Can we reduce it even more? Yes, we can. Again, they're both even. Divided by 2 is 8 divided by 2 is 4. I'm going to give myself a little space. And 10 divided by 2 is 5. Okay, can we reduce 4 over 5? Nope. So our cosine of A equals 4 over 5. Beautiful. All right, let's look at number 5. It wants cosine of x. A lot of cosines. Here we go. Cosine of x. X is right there. Now let's identify opposite, adjacent, and hypotenuse. So I got my hypotenuse is always across from our right angle. Okay, my adjacent is the side that's next to that angle. Adjacent. And my opposite side on the other side. Okay, so cosine of x, which two sides do we need with cosine? Again, adjacent over hypotenuse. Adjacent, 24, over hypotenuse, 40. Okay, can we reduce this? Yes, we can. they're actually both divisible by 4. Let's try 4 this time. Okay, 24 divided by 4, I believe, is 6. Let's just double check that on our calculator. Yep, 6 over 40 divided by 4 is 10. Okay, can we reduce it even more? Yes, we can. We can divide each one of these by 2 again. Okay, 6 divided by 2 is 3, and 10 divided by 2 is 5. Okay, we can't reduce that anymore, so we know that cosine of x equals 3 over 5. Beautiful. Okay, last example where we're just trying to set up the ratio, the fraction. 6, we want sine of z. Finally, we get a sine in here. Okay, angle z right there. Okay, let's identify opposite, adjacent, and hypotenuse. Hypotenuse is always across from that right angle. Adjacent is next to the angle. And opposite is on the opposite side. Okay, well, which two sides do I need with sine? Okay, so opposite over hypotenuse. Okay, so we know that sine of z equals opposite, 16, over hypotenuse, 34. Okay, let's go ahead and reduce it. What can we divide both of these numbers by? They're both even, so we can divide them by 2 at least. 16 divided by 2 is 8. 34 divided by 2 is 17. Okay, can we reduce that anymore? No, we cannot, so we know that sine of z equals 8 over 17. And there's our final answer. Okay, so that was simply setting up the ratios given the angle and the function that it wants. Okay, now in numbers 7 and 8, it wants us to find the missing side. Okay, we did some practice with finding the missing side using Pythagorean theorem, and that's where it gives you 2 angles. Okay, well now it gives you Pythagorean theorem is where we solve for a missing side when it gives us 2 sides. Okay, but it only gives us 1 side and an angle. Okay, so now we have to use a trigonometric function, meaning either sine, cosine, or tangent. Okay, and we're going to do that by setting up the ratio. Okay, so the first thing we want to do is find the angle it gives us. Okay, so it's giving us this angle of 59. Okay, so based on 59, let's identify the two sides now that it's giving us. Okay, so 18 is across from that right angle, so we know that's a hypotenuse. And then x is right next to it. That tells me that's an adjacent. Okay, so I have adjacent and hypotenuse. Which trigonometric function am I going to use? Sine, cosine, or tangent with adjacent and hypotenuse? Cosine, adjacent and hypotenuse. Okay, so we get cosine of the angle. Remember, the function always goes next to the angle. So this time the angle is 59 degrees. Equals adjacent x over hypotenuse 18. Okay, well now we're trying to solve for x. So looking at this side with my x, I need to get rid of divide by 18. How am I going to get rid of divide by 18? We are going to multiply by 18. So times by 18. To get x by itself, we got to do the same thing over here. Okay, so my x is now by itself. So this part is where we just put it into a calculator. So you're going to need a calculator. Clear. So we have 18 times, okay, I have my little cosine button right there. Cosine of, it gives you a space to put in, 59, and enter. Okay, it wants us to round to the nearest tenth. That means the first place after the decimal. Okay, so if it wants it to the first place, you have to look at what's after. Okay, so since the number after that 2 is a 7, okay, remember 5 and above, we have to round up. Okay, so since it's a 7, that turns that 2 into a 3. So our answer, 9.3. And there it is. We know that this missing side, x, is 9.3. Beautiful. Okay, last one. Let's look at number 8. So first, identify the angle that it gives you. Gives me 62. Okay, and now what two sides does it give me based on this angle? Okay, so it actually doesn't give me the hypotenuse this time. There's nothing across from my right angle. Okay, the x is right next to that angle, so that is my adjacent. And the 17 is on the opposite side, so that's the opposite side. Okay, well now we need to identify what trigonometric function uses opposite and adjacent. Which trigonometric function uses opposite and adjacent? Tangent, or t. Okay, so how we set it up, tangent of the angle, 62, equals opposite, 17, over adjacent. Oh my gosh. You guys are gonna freak out because now my x is on bottom. What do we do? Okay, do not freak out. There's just one more step we gotta do. Well, if our x is ever on bottom, we need to get it off the bottom because we can't solve for it if it's off the bottom. So how do we do that? What's the opposite of divide by x? We times by x. Okay, so now what we have is x times tangent of 62 equals 17 is left over there. All right, so now we're looking at this side, no big deal. So the only thing I need to get rid of to get my x by itself is get rid of this times by tangent of 62. Well, what's the opposite of multiply by tangent of 62? We're simply going to divide by tangent of 62. Easy peasy. Divide by that whole piece. It cancels out. Got to do the same thing over here. Tangent of 62. Okay, so now in our calculator, to get our x, we just have to do, clear, 17 divided by tangent, find your tangent button, tangent of 62. And we want it rounded to the nearest tenth. Well, it's 0, okay, the one after it is a 3. That's not 5 or above, so this is going to stay 9.0. And yes, I want you to write it as 9.0, not just 9. Okay, and there we go. Those are our notes for today. You have an assignment that goes with them.